Hi, and welcome to our last lesson about the standard normal distribution. We'll use information from this lesson all year long, but this is our last day to learn about it. So we heard before that about 68% of the area under the normal curve lies within one standard deviation plus or minus from the mean. Specifically, we can find the amount of area that should be within an interval in the standard normal curve. And we're going to look at a couple of other intervals centered around the mean that we ought to really know a little bit about. So first we're going to ask you to think about this, finding the probability that a z-score lies within two standard deviations of the mean. I want to draw the picture because I think that's helpful. And we'll ask you to think about this. Two standard deviations is out here, so kind of like that. We want to know the area that's between -2 and z and 2. As you think about this, our z-table can tell us the probability that you lie anywhere below a z-score of 2 and that you lie anywhere between a z-score of -2. But when we're doing a range like this, what we end up having to do is a little subtraction. We will take the probability that z is less than +2, and remember that would give us everything to the left. Then we will subtract out of it what we don't want. That is the probability that z is less than -2. I'm going to ask you to use your table to look those probabilities up and do that subtraction. So will you pause the video and do that, please? I did my lookup, and this is what I found. The probability that z is less than 2 is 0.9772. The probability that z is less than -2 is 0.0228. I subtract those and see the probability between a z-score of negative and +2 is about 95%, okay, 0.9544. We're going to do that for the interval between a z of -3 and +3. We're talking this is going to be almost the entire area, because as you know, once you get past those 3 standard deviations plus or minus, you're out in very rare territory. So let's do that again, please. Will you pause the video and let's find the area of the curve that's between -3 and +3 in z. Here's my calculation. Very large probability, almost 100% within 3 standard deviations of the mean. I'd like us to try and get a little resource going here, a recap of that information, if you will. Now, between -1 standard deviation and +1 standard deviation from the mean, if we carry it out to the 4 decimal places, that is 0.6826 of the probability. 68% we said, and it is close to that, 68.26. I'm going to ask you to do this for me. Zone up your standard normal curve here. Since there is some symmetry, we know that half of that 68% is here and half here. That would make this 0.3413 as this, 3413. And so we can say that in the interval between the mean and 1 standard deviation, about 34% of the data resides there. We just figured out the percentage that's between positive and -2 standard deviations, and that was 0.9544. Was that right? Yeah. 9544. Now, to come up with these little pieces, we got to do a little work. If we take that 0.9544 and subtract out the stuff in the middle, 0.6826, that's going to leave us with I need my 0.2718% to be divided between these two areas. So I'm going to divide that by 2, and I'll get 0.1359. 0.1359 in here. So 1359. 0.1359 And we're getting ourselves a good little resource here about the standard normal distribution. We figured from -3 standard deviations to +3 that 0.9974 or 99.74% of the probability is between here and here. Using a similar technique, we can judge the amount of probability here and here. I'm going to ask you to do that. You want to subtract 9974 minus this stuff in the middle, 9544, then cut it in half. Will you pause the video and do that, please? I did that calculation. I have about 2.15% of the area under the normal curve between 2 and 3 z-score and -2 and -3. Now that leaves a little bit left over for the outsides, and then we can figure that easily as well. If you take 1 and subtract this, you'll have 0.0026 and divide that into half, 0013. So beyond 3 standard deviations, that is so rare. 0013. In a normal distribution, if you got something, remember we said before, 5% or less is considered rare. This is extremely rare. Okay, this will be a handy thing to keep. So we just want to remind you, when we have tests, quizzes, homework, this little thing can help us a ton. I'd like us to talk just a little bit about now some different intervals. We want to find z-scores that contain the middle so-and-so percent, 90 and 95 we're going to do. We will use these things a lot as we go through the year, so I want to have you get a picture in your mind of what's going to go on here. We want 90% of the values to be between, or the middle 90%, to be between 2 z-values, which we can look up. If you think about this, the total area under the normal curve is 1, and if we subtract the middle 90%, that leaves 10% to be split at each end. Folks, we need to know a z-score that traps then 5%, half of that 10, at each end. And the easy way to find this is to look on the negative side of your table. Look for the z-score that traps 0.05 below it. So will you pause the video and do that? That happened right on a boundary. The z-score that does that 5% underneath is exactly halfway between -1.64 and 1.65. So -1.645. The symmetry of the curve tells us that the top z-score, the positive one, has to just be the positive 1.645. So 90%, the middle 90% of values are within plus and minus 1.645 on the z-chart. Okay, 90%. I want to ask you to do the same thing for 95%. And by now you know the drill. That's going to put us out farther. 95 in the middle leaves only 5% to be split between the two ends. That 5% has to be divided evenly, so 0.025 at each end. Again, if we look on the negative side of the table for the z-score that traps 0.25, we'll have our boundary. Ooh, you can hit that one straight on. That was -1.96. And by the symmetry of the curve, the positive z-score on the other end, 1.96. So 95% of the data in any normal distribution will be between positive and -1.96 in z. Okay, that's pretty cool. And those scores, we'll use these a lot as we go through the year. Folks, that's the end of our lesson today on central intervals. We ask you to get out there and try that. You try, and we will see you in school.